Hey everyone, welcome back to another episode of Ask GN. As always, if you have questions for our next episode, leave them in the comment section below or on the Patreon Discord. If you support us through Patreon, you can leave questions in the Ask GN channel. It's been a couple weeks since we did one of these. We were at CES, so there were a lot of questions logged. I've got a good amount of them here, but I probably won't get to all of them. So if I miss you, post it again below. Before that, this video is brought to you by the Gamers Nexus Patreon and our Patreon backers. If you want to help us out directly, you can go to patreon.com/gamersnexus, where we have access to a Patreon-only Discord where you can chat with the GN team, or you can support us at $5 or higher and get access to behind-the-scenes videos as we release them once or twice a month. Learn more at the link in the description below. I want to start out, though, with Microcenter. And I guess this is just graphics cards in general, but man, Microcenter, what's going on over there? This is like, we're the champions of PC builders. We give you the best deals and hugely discounted CPUs or cheap or free motherboards with the purchase of all these other things. And then when it comes to graphics cards, they're like, you know what? This is a trend we can get behind. $1,500 Asus 1080 Ti Strix. That sounds fair. So before getting into this one, we just posted that GPU video. What do manufacturers think of crypto miners? And that talks about a lot of elements outside of crypto mining, like memory prices and things like that. What I mentioned in there also is that the difference between primary and secondary sellers on Newegg and Amazon means that you'll see $1,500 or $2,000 GPUs, but they're not sold by Amazon or Newegg. They're sold by third-party sellers on Amazon and Newegg's marketplaces. So it kind of looks the same, but it's not. There's a gigantic difference. When the cards are in stock, they tend to be less insane than those prices. They tend to be closer to MSRP, maybe slightly above. You don't really see the outlandish prices in the US anyway with those two websites, except for the third-party sellers. Microcenter, we had a GN team member visit one in Michigan recently, and they had a 1080 Ti Strix for $1,500, limit one per household. Why would you even limit them at that? You're like raking in so much money. Let them buy as many as they want. What do you care? You paid way less than that. You paid less than $800 for that card. So it's just stupid. It's like trying to appear like you're doing something to limit the consumption of the card. So you multiply the price by some factor, and then you limit it to one per household. It does not make any sense. You can buy Titan XPs for cheaper than 1080 Ti's, and you should. It's like for the whole last year, we're like, don't buy the Titan XP for gaming, buy 1080 Ti. Well, ideally you don't buy either, because they're not good value for right now, unless they're like $800. But if you really need one today, screw the 1080 Ti at $1,500. Either go camp at a store, not Microcenter, and buy one for a reasonable price, or buy a different card, I guess. So yeah, Microcenter, they had GTX 1060 FTW gaming 6GB cards. Let me just repeat that. GTX 1060. What was the price of that? $250 or thereabouts. That card is at this Microcenter for $630. Limit one per household, because while we're taking 3 times the original price of it, we still want to make sure we appear like we're serving gamers. So yeah, they have apparently a BYOD, I think it's build your own discount, that one of the GN Patreon members was talking about, and I confirmed this online with a couple others as well. So Microcenter claims that you can appear in the store, you have to find a manager, and they will apparently give you a better price on the video cards than what's shown on the shelves if you buy other components there, which is actually reasonable, because if you're a PC builder, you're buying multiple parts for a PC, then yeah, okay, you're buying a CPU anyway. You know what? Tell Microcenter you're buying one, and hopefully they give you closer to MSRP for the GPU. That sounds great. Sounds like they're being the champions of PC gamers again. We tried that at this Michigan location, and what they told us was, let me find the quote here. So regarding the $1,500 Asus 1080 Ti Strix, when we said, what about a discount if you buy multiple components, they said, that's what it's selling for on Newegg and Amazon. So I think your mileage may vary depending on the store and who got the memo and who didn't. Either way, here's the difference. If a retailer is selling them at those prices, as opposed to a third-party reseller, it's kind of an egregious breach of trust for the community and the customers you have. It's completely outlandish. This is like absurd. If it's just Newegg, who has a third-party seller listing a 1080 Ti for $1,500, whatever. You might as well go to eBay and complain about prices there that are outrageous too. But when it's Microcenter directly, that's wholly unacceptable, and I think they should be condemned for it. But hopefully they'll wake up and maybe all of the stores can get the memo on the build your own discount or whatever they're calling it. But yeah, that it's pretty. See, at this point, knowing what it costs to make a GPU and knowing everything we do from the GPU "What do manufacturers think of miners" video, go watch that if you haven't before you comment. But knowing all that stuff and the cost change, the retail prices we're seeing here, whether or not it's Microcenter's fault, someone in there is gouging the hell out of everybody. And I would have to say it's probably closer to the retail side of the chain than not. So definitely very disappointed in Microcenter. But let's get into some of the questions. So this one is from Discord. BillyONeal says, AskGN, regarding the recent GPU prices video, fitting, did any of the manufacturers with whom you spoke consider using their position as a board maker to run miners themselves? Thanks. We joked about this a bit with a couple people. So I probably would not be given fully honest answers if anyone did have a mining operation in their warehouse. So keep that in mind. But depends on who I'm talking to. We have better relationships with some of them than others. But we kind of joked about, if these cards make so much money, why don't you guys just mine with them? It doesn't really work that way. There's investors involved and things like that. And so the investors want to see the product moving off the shelves. That said, there was a lot of joking at CES about, actually with I think at least two vendors, about, what we should do is we should give away a heating unit, like just a space heater. We should give them away with an Ethernet cable, tell people to plug it in and let it mine, and then it mines the currency to the manufacturer, and the heating element was free, which was just a joke, but actually kind of brilliant in an interesting way. So that's about the extent of the question you're asking, I think. Not really. Most of the individuals we spoke to at the companies, you have to remember these are individuals, I would say have a tenuous belief in mining in general. So obviously that's not the company, that's the individual, but that should pretty much answer your question as to why they would not do that. Next question is Yousuf, who said, I've been mining with my Gigabyte 1080 Waterforce for almost a year now on my main rig. It still runs perfectly. It's an AIO card. I wanted to bring this one up to address an important point that seems to be misunderstood. Failures don't typically happen like degrading performance. It doesn't matter if it's mining. You could be running Firestrike for a year and your score might be the same in a year as it is today, variance notwithstanding. So when you see failure, depending on the type of failure, it's more likely that it to quote a reply to that comment on YouTube, it runs perfectly until it doesn't, which actually makes a lot of sense because it runs perfectly and then it stops. There's very little indication of failure in between there. The typical indications of failure might be fans dying, so you'll see thermal throttling, you'll see clock dropping, stuff like that. In an instance of fan dying, yes, you will see a decrease in performance. You'll be able to look at the card, identify the failure, the fan, and replace it. If that's not the point of failure, you have other options like memory failure from overheating, pretty uncommon, or more likely a power component of some kind just reaching end of life. Electrolytic capacitors are a great example of this, where if you have one that's rated for 105 degrees Celsius, 5,000 hours, and it's running close to that. This is an instance where with capacitors, the closer and closer you run to its spec, it will have an impact on lifespan. Whether or not you ever know depends on what it's rated for, because yeah, of course you're wearing down the life of the component just by using it, but if it's within spec, if it's running pretty cool, you're probably going to replace the system or the component before the usable life of that capacitor expires. So not commonly a problem. However, if you're putting it in a high load, high stress environment with poor cooling, which not the case for a liquid cooled card, but there could be capacitors in there that aren't liquid cooled. If you have something in there that starts running hot, say it's getting close to the 100-degree mark, which is not unreasonable for a graphics card, as we've shown in many tests. If it's getting near that mark, you run it for 5,000 hours, so you maybe get a couple years out of it or something if it's on and off and not 100% load 24/7. But as you approach the end of that rating, and it's different for every specific part, but as you approach the end of it, it's possible that one of those capacitors pops. They start ballooning. So you look at the capacitors, if there's some that are kind of like bulged out and look like they're going to explode, then it might be that the card is nearing a point of failure. And when it does pop, it's probably just going to stop working. This is something that you could see with some power stages that were used on the EVGA ACX cards, I guess 2 years ago now, before they issued the fix, where there was a bad supply of components from a component supplier to EVGA, and those could blow up under adverse bad conditions, basically, because there were videos of it with ACX cards. So yeah, I think the point here I'm making is that if you're like, well, I've been rendering with, or I've been mining with my GPU for 2 years and it's fine, why do people talk about parts dying? Sample size of 1, and you're not going to see worse performance. It's just going to stop working, and then you'll stop commenting about how great it's been working. So that's not to say you should be concerned or anything. Just keep thermals in check. See the previous askgn. We have a long discussion on thermals in there. Everything comes back to heat. Heat is the catalyst for all failure in computers, for the most part. Heat and voltage. So yeah, I think that pretty much sums up my points on that one. But basically, keep it cool, and if you're feeling cocky because your card hasn't failed, it doesn't mean that you're out of the woods. Next one, Pike said, this shit has been bugging me to no end. If a 1080 Ti puts about 300 watts overclocked and an i7-8700K puts out less than that, even with a hard overclock, then why can a 1080 Ti be cooled with a 120mm cooler, but the 8700K needs a 240mm plus cooler? This is a great question. A lot of this comes down to two main things: die size or dissipation area and direct contact. The GPU in that instance, and for anyone not familiar with these tests, Pike here is correct. You can put a 120mm CLC on a GPU like a 1080 or something, 1080 Ti, and you'll be operating at 40 to 50 C with an ambient of, I don't know, maybe 20 or so. It works very well. If you put the same cooler on an 8700K, it's going to struggle hard. I mean, you're going to be nearing, depending on your voltage, you're definitely way higher in temperature than the GPU would be comparatively. So the reason for that primarily is because of the direct die cooling. The GPU die is exposed directly to the cold plate. The CPU has an integrated heat spreader on top of the die, between which there is thermal compound, and then on top of which there's thermal compound, and you've got nickel-plated copper IHS in between them. So it's got more media to transfer through, and when you have more transfer media, you're dealing with just worse and worse transfer of that energy as you keep pushing through all those interfaces. So that's part of it. We've kind of demonstrated this by delidding CPUs and using liquid metal. Look at any of our liquid metal tests. You can drop anywhere from 8 to 20 degrees Celsius depending, and by adding liquid metal. So that's one component, is the thermal compound between the IHS and the die is not very good. And then the other component is there is an IHS. That adds to it. And then you have the die size. A GTX 1080 Ti has a larger die than a lot of the CPUs on the market, if not most of them. And that's more area for the heat to be distributed through. So it's not as concentrated on just whatever few cores there are on the die on the Intel CPU in this instance. So that's most of it though. Thermal transfer, direct die contact, and dissipation, or die size and dissipation area. Thermal density basically is what it comes down to. NoRYZEN 2000, A New Hope, says, what is the most important tool GN uses that you would recommend for most enthusiasts to have? I would say the most important tool is a software tool, and it's Hardware Info 64, and everyone should have it. It's very good. I encourage you to go into the options of it and not just use it out of box, because the options are pretty powerful. You can do a lot with it. It's probably my favorite software solution for looking at any stats at all really on the computer, not just thermals, but it's got all kinds of sensors for the high-end motherboards that you may not even know were in there, like VRM sensors, stuff like that. It's pretty sweet to really dig into it. Other than that, a current clamp would be high up on my list of must-haves. Digital multimeter would be high on my list, and I like keeping around different types of thermal compound, liquid metal, things like that, just to have in case I need it. And I normally keep like this is the good stuff, this is the okay stuff, and then if I know a cooler is just going to be on something for a couple hours or whatever while I do some unrelated non-cooling focused test, I'll put the cheaper stuff on there. So that's kind of what I like to do in terms of accumulating tools. Stuff like thermocouples, not really needed for most enthusiasts. So yeah, I'd say Hardware Info 64, current clamps, digital multimeters, and a nice toolkit like the iFixit ProTech toolkit. We like that one a lot, or their 128-bit kit. Those will allow you to open pretty much anything on the market. Next one, Contractor 316. What are the 3 biggest or most wanted areas of test methodology, pieces of equipment that time and money and practicality currently prevent you from pursuing? I would say power supply testing's up on that list. Power supply testing is interesting. It requires very expensive equipment to do it properly. Actually, monitor testing's in here too. I'll get to that in a moment. So power supply testing, short of calling it an overview, opening the box, and talking about the cables, there's not a lot you can do with power supply testing without buying some good equipment. And the former isn't a review, so we don't do it. It's an unboxing. So you start looking at stuff like chroma rigs, or what are they, Sun Moon, I think they're called, stuff like that. It gets expensive fast. And the problem with power supply reviews is they don't get a lot of traffic. It's not a highly searched item. A pretty small group of enthusiasts really care about their power supplies enough to look up professional reviews of them, as opposed to just check an aggregate Newegg score. So the money that we can make from a power supply review is pretty low, and if we can even, we probably make money on it up until the cost of the equipment required is factored in, at which point it may be more or less impossible to profit on it anytime in the foreseeable future. I mean, like, you're talking more than a year ROI, which is pretty bad. So especially considering we have a limited amount of time, that is a fixed resource. I can't create more of it. So if my time can be spent testing other things that are, 1, I'm more of an expert in, 2, they are more accessible, 3, they're more interesting to everybody on the internet, and then 4, it's the tools are more accessible, then obviously the time is better spent there. Like, it's pretty much, I think everyone can, if you think through the process of why you would choose to learn how to test, for example, fans in depth versus testing power supplies, you can see where the cost difference is to get into it. It's not even just ROI, it's can you even afford the tool to start the testing? And a lot of that stuff, the answer is no. It gets really expensive really fast, tens of thousands of dollars. So that's one thing. We're looking into power supply testing. It may happen, but it's not easy. So that's definitely one aspect. Another thing I would like to test is monitors. So we talked to the VESA group and DisplayPort people at CES, and they showed us some monitor testing. To really do it right, you need expensive software, and you need a bunch of tools and calibration tools, and maybe high-speed cameras ideally to double check the manufacturer specs. And if you're not testing all of those things, it's not really an objective review. You're leaning a lot on how does it look, and that's, I mean, it's already pretty hard to convey through a camera because the camera might not shoot at the same quality the monitor's putting out, stuff like that. So, and then the viewer doesn't have a monitor good enough to see the quality of the monitor they're trying to watch reviews for. So you really need objective numbers, and we're just not there yet. I think there's a thermal chamber I would love to have, but that takes a lot of space and is also expensive even if you buy an old one. So yeah, those are the three key things I think. They're all very expensive wants. In the case of monitors, it's just a lot of time. And then, let's see, Soren asks, I was recently told by a teacher that you should never hold hardware by copper contacts because you can get oil on them or ESD into them and destroy the entire piece of hardware. If this is true, why do nearly all tech tubers hold hardware, such as video cards and RAM, with their fingers on the copper contacts? So a couple of things, there's two sides to this. One is, it can go kind of either way. The teacher is correct. Electrostatic discharge is a thing that's real and exists. And anyone who says otherwise is an idiot because it's science. It's very easily proven. So electrostatic discharge is a thing that happens. Now, you can shock components. I could have a charge on me right now if I didn't just touch this, but if I had a charge and I touch the back plate, chances are if I discharge electricity into that video card's back plate, it'll probably be fine. The same is true for the shroud or really the heatsink. Most things, there's a lot of ground plane in there. If you touch the GPU core, there might be a problem, or some sensitive SMD, surface mount device, on the PCB, there could be a problem. And 10 years doing this, I've killed a lot of components from electrostatic discharge. One of our oldest How Do Motherboards Work videos from many years ago, we probably spent about an hour filming it, and it was me and Patrick Stone, spent an hour filming it, handling the same board the whole time, never grounded ourselves, on carpet, and it was dead at the end of the shoot, and it worked fine at the start of the shoot. The only reason that happens is ESD. So it's definitely something that happens. That said, there are specific conditions really kind of required to get an electrostatic discharge that's fierce enough to hurt something, and also conditions where you have to touch the component in the right place, because it's possible that it finds its way out to ground rather safely and doesn't hurt anything. It's also possible you touch the exact wrong thing and destroy it. So first, let's think of the voltage requirements. In order to feel an electrostatic discharge or see it, like when you touch a car door, it's got to be thousands of volts to really notice it as a human. So that's pretty high. The components that are most sensitive, like a GPU or CPU, are used to dealing with things like 1 volt by the time it's all filtered down and gets to them. So you can see why there would be a problem. But again, you really have to touch the exact wrong thing for it to be a problem. As for oils and handling contacts and things like that, it is bad practice to pick up the card and hold it by the PCIe slot, for example, right there. It's another form of potential damage. That's pretty, the oils on your skin probably aren't going to cause problems. It's possible if you're somewhere like Taiwan, and we've seen this in person, where the humidity is just insane all the time and you have like USB ports, there's a valid use case for gold-plated ports and things like that in a high humidity environment because of corrosion. Touching the PCIe slot isn't going to cause corrosion unless you're an alien. So the only real concern is ESD into the contacts or something like that. Oxidation isn't really that much of a concern. Just kind of make sure you're grounded. Ideally, you just don't touch them. Pick things up by like the back plate, the shroud, the expansion slot, things like that, where you're less likely to cause damage. Whenever you're touching a bare PCB, it's possible you could hurt it. That said, we get hands-on with this stuff constantly, even without grounding throughout the whole process. You just kind of tap it once, and most of the time it's fine. I have killed stuff though, so it does happen. But yeah, I think the reason I'm taking so long to answer that is because I don't want people to think that it's blown out of proportion in terms of there's like two camps to it. There's ESD isn't real, which is stupid, and there's being hyper paranoid of destroying anything by touching it, which we also see when I move PCBs around in teardowns. People are like, why are you so hard on the components? They're fine. So just find a middle ground between those two camps and you'll be good. But yeah, that's a good question though. See, last one is Timber Meadow, who said, still interested to hear about IT certifications, and this is also previous job experience, I guess, if I remember correctly, from the question in askgn-66. So yeah, I forgot to answer that one then. I don't have any IT certifications. I have work experience. So other than doing this, I a long time ago did web development. I did test engineering, so worked at Dell for a while doing test engineering and validation. So the job there was basically whatever components we were testing, we would develop a test plan for how to break them through reasonable user means or extreme means, attempt to break the component, not like with a hammer, but like through use, and then report those problems to the developers or the engineers to get them fixed. We did a lot of stuff. We had a lot of projects going on. But yeah, it was mostly developing tests, following through test methods, creating test cases where you have a spreadsheet that's like step 1, 2, 3, 4, pass or fail for all of them. There's some other cool like shock and vibe testing equipment that was in there, which is stuff that you'll see in the industry where basically a shaking table will rattle the hell out of laptops and stuff like that to see at what point does a component come loose or does stuff break or lose connectivity. I also did validation testing for CAE software, computer-aided engineering, parametric analyzer software I tested, worked with signal integrity software and testing of signal integrity software to make sure things like dielectric materials had the right values, insulators had the right properties attached to them, worked on field solver testing, stuff like that. So basically it's all testing. All the previous experiences, it's all testing, all of it. So that's it for this one though. Subscribe for more as always. If you want to leave a question, post it in the comment section below or in the Patreon Discord. If you want to join the Patreon Discord, go to patreon.com/gamersnexus. Thank you for watching. I'll see you all next time.